Going on, guys? In this video we are going to see how to find the general solution of the non-homogeneous second order differential equation using method of undetermined coefficients. Now the first thing we have to do is we have to find the homogeneous, we have to make this one into homogeneous second order linear differential equation. That would be like y double prime plus 3y prime plus 2y is equal to 0, and we solve this one in a usual way. So here in this kind of question what we do is we bring this one into quadratic equation pattern. So that's gonna look like r square plus 3r plus 2r is equal to 0. Then we find the roots, and here let's see whether it is factorable. And actually this one is factorable. So when we multiply we have to get 2, and when we add we have to get 3. So that's gonna be just 2 and 1, right? So r square plus 2r plus r 2r will work is equal to 0. Now we can factor this one. R plus 2 and r plus 1 is equal to 0. Therefore r is going to be equal to negative 2 and r is equal to negative 1. Here we are getting distinct roots. So the general solution of this differential equation is going to be look like this. Yc is equal to c1 e power r1x plus c2 e power r2x. So the r1 and r2 can be any root. You can switch it around or keep it as it is. It doesn't matter. I take this one as r1, r2, and this is going to be the general solution of the homogeneous differential equation. And the original question is non-homogeneous. To find that one, what we have to do is we have to find the particular solution after this. Now let's write the general solution of this one first and go for the other part. So this is going to be c1 e power negative 2x plus c2 e power negative 1x. Okay, so this is going to be the general solution of this homogeneous differential equation. Now next step is we are going to find the particular solution of this homogeneous differential equation. So what we do is we take this part again. Actually we take the non-homogeneous part, and that's going to be y double prime plus 3y prime plus 2y plus equal to x square. So here we are going to use method of undetermined coefficient. So what we do is we take a polynomial and we think about that, like if we find the derivative, for example if we find the second derivative and plus with the first derivative of that function and multiply by 3 plus the main function times 2, we expect that one to give x square. So this is a tricky part in this question, like we have to think a little bit about it, right? And here what I'm going to do is I'm going to take the second degree polynomial and hope it will work. Like this is going to be ax square plus bx plus c, and I equate this one to particular ypx. Okay, and let's take the first derivative yp prime, and if you take the first derivative this one, this is going to give us 2ax plus b, right? And if you take the second derivative this one, that's going to give you just 2a, right? Now what we are going to do is we are going to write this equation in terms of this first derivative, second derivative and the main function. So y double prime we found out right here, that is, let's write this one clearly, y double prime is 2a. So I'm going to write this equation in this pattern. So y double prime is 2a plus 3 times y prime. Y prime we found out that one right here. So that's going to be 3 times 2ax plus b, and then after that 2 times y. Y is our main function, this function right here. That's going to be 2 times ax square plus bx plus c. Okay, that is equal to plus c, that is equal to x square. So we equate this one to x square, and let's simplify this one. So here we are going to have 2a plus 6ax plus 3b plus 2ax square plus 2bx plus 2c is equal to x square. Okay, now let's go ahead and bring the like terms together. And if you look at the powers, the degrees, x square is only one thing we have right now. So I bring this one to the front. This is going to be 2ax square. And x value, the power 1, we have two of these things. We have ax and this bx. So we can take that one common. So I factor this one out like, let's take, here we can take x common, and also we can take 2x common. Okay, so if I take, or just keep the x common, because we are going to equate the coefficients. In that way we can find the ABC value easily. So this is going to be 6a plus 2b, and then I'm going to just keep the constant together. First we have 2a, and then we have 3b, and then we have 2c, that is equal to x square. Now if you remember that partial fraction decomposition pattern, I'm going to do the same technique right here, right? I'm going to equate the coefficients. So if you look at the other side of the equation, we have x square, and we don't have any x value. So we consider that one as 0x, and we consider the constant as 0, and we are going to equate each of them. For x square, we have 2ax square. So 2ax square, forget about this x square, just 2a is equal to 1, because we just look at the coefficients. For this x square, we just has one in front of this one, so we equate this one to 1. Therefore a is going to be equal to half. Now let's look at other things, and here we have x, and the coefficient is 6a plus 2b. So 6a plus 2b is going to be equal to 0, because we don't have any x value on the other side of the equation. So this is going to be 0, and we found out the a value already, that is half, and this one multiplied by half is going to give us 3. So 2b is going to be negative 3. If I move to the other side, negative 3. Therefore b is going to be negative 3 by 2. Now we have to find out the c value, and constant. If we equate constant, that's also equal to 0. So I am going to write that one right here. 2a plus 3b plus 2c is equal to 0. Okay, now we have the a value, that is half. So 2 times half is going to be 1, and we found out the b value, that is negative 3 by 2. If you multiply this one by that, that's going to give us negative 9 by 2. Negative 9 by 2 plus 2c is equal to 0. Now 1 is same as 2 by 2. So 2 by 2 minus 9 by 2 is going to give you negative 7 by 2. So negative 7 by 2 is equal to 2c. Therefore 2c is equal to 7 by 2. Therefore c is going to be equal to 7. Now we found out the a and ABC values. Let's box this one so it will be clear. We found out the ABC value. Now what I'm going to do is I'm going to write the particular solution. So instead of this ABC, I'm going to replace these values. So yp, the particular solution of this differential equation, is going to be half x square, because a is half x square, and then that's b is negative 3 by 2, negative 3 by 2x, and the c is constant. We found out that is equal to 7. Okay, I think there's a mistake in finding constant, because if I move this c to the other side, this is going to divide, right? So that's going to be 7 over 4. So here we have to have 7 over 4 right here, and that's going to be here. Okay, the constant is going to be 7 over 4. Now this is our particular solution of this non-homogeneous differential equation. Now to find the general solution of this non-homogeneous differential equation, what we have to do is we have to add the general solution of the homogeneous differential equation we found out before, that is this one, and then we have to add the particular solution of the non-homogeneous differential equation, that is this one. If we add both of them together, that's going to give us the general solution of the non-homogeneous differential equation. Now in order to do that, we had to have some space. I'm going to erase this one. Okay, let's erase this part. and continue right here. Okay, let's write this one down right here. So let's call the general solution of the non-homogeneous differential equation as y of x. That's going to be equal to yp. That's particular solution of the non-homogeneous differential equation, and the general solution of the homogeneous differential equation we found out before. And let's go ahead and plug the values. Particular solution is half x squared minus 3 by 2x plus 7 over 4. And the general solution of the homogeneous is c1 e power minus 2x plus c2 e power minus x. Okay, so there's no way we can simplify this one, so we can keep this one as it is. So this is going to be our general solution for this non-homogeneous differential equation, and that's how we do this kind of problems. I hope this helps. Thanks for watching.